Okay, today we go into new chapter, chapter 6. Okay, chapter 6 is also rigid body, but we start to apply chapter 5 already introduced how to find second moment of inertia, I, and then how to draw kinetic diagram, free body diagram for rigid body. Now, in chapter 6, you start to apply the force and acceleration, where we will see principle of energy, principle of so and so in your solution. Okay. Okay, we start to look at what is moment of inertia. So your static should already learn what is the second moment of inertia, Ixx, Iyy. So this is just a recap of your static chapter, right? So what is moment of inertia? So this is an example of flywheel. So this is a flywheel where it will generate energy for the engine. One is turn, it will continue to turn until you apply a friction or apply a resistant force to the engine. Okay, this is a flywheel. So we start to derive equation for second moment of inertia. So let's say you have a body, rigid body, and we start to look into the effect of mass, the effect of mass compared to the previous chapter. So here on the body, we focus on one part of the small mass that written as dm. And then this mass, we assume that when this body have a motion, this body will rotate along the z-axis with the distance r from the z-axis. Right. So we now start to define the second moment of axis. Again, what is moment? Moment, how to calculate moment? You take force multiplied by distance, and it must be perpendicular, right? So when you see a circle, when you see a circle, collinear motion, you know that every time you need to split your acceleration into tangent and normal, right? So same, when you have body rotating, let's say this is dm. So again, what is moment? Moment equal to force and multiplied by d. Both must be perpendicular with each other. So there must be a force at this direction and perpendicular to the radius of distance. Okay. So this one already learned in your statics, so I won't spend much time in this. You should already know. I equal to integration of r squared dm. All right. So again, this one you should learn in your static. So you integrate your r squared dm, you get your second moment of inertia. Right. And mass moment of inertia, need to take note, is always positive. Right? Always positive. Huh? And the common unit for your moment of inertia is kilogram meter square. Right? Why kilogram meter square? R is meter. Meter you square, you get meter square. You integrate your mass, you get kilogram. Right. So how do you calculate mass if you have density? How do you get mass if you have density? Yeah, divide by volume. Huh? What is density? Huh? What? Mass over volume. This is rho. So how do you get back volume? How you get back volume? Sorry, how you get back mass? Volume times density. Okay, so the m here we can change with in term of rho and v. All right. Dm equal to rho v. So you change your integration equation, dm equal to rho dv. Okay, makes sense? Now, you know that for all the rigid body, your density is fixed. It's a constant. So when you integrate some constant, what you do, you pull the constant out. All right. So you simplify your second moment inertia, I equal to rho integrate r square dv. Right? Now, when you do integration, how you find volume? How you find volume? How you find volume? What are the ways of finding volume? Huh? Length equal to volume. Uh-huh. Length in multiply by width and what? Height. All right. So any one of these will give you area times the height or times any parameter. Right. Okay. Area is very direct. You know that you have a lot of shape. The most common one, square, circle, polygon, triangular, and so on. So go and refresh how to find polygon area. Okay. Especially non-linear triangular, you need to use cosine rules. Okay. So you have three methods of finding moment of inertia. You start with integrate r squared dm. You break dm into rho and velocity volume, and then you can break your volume into parameter that you know. Okay. So here in your first year or second year, when you learn max 2 or max 3 that involve triple integration, it will give you volume. So remember, yeah. So when you integrate dx, you integrate dy, integrate dz, you get volume. Yeah. So again, this is your homework. Go home and revisit. If you're weak in triple integration, go home and rework on your triple integration. Okay. There are few methods to do volume calculation. We start to introduce you a method called shell element. So let's say we have this blue color body, and we want to calculate the volume of this small shell, right? So how do you calculate this small shell? You're having from the center to the y, and there's a change of dy, and then you have a jet height. So how do you calculate the volume of a cylinder? How you calculate this volume, the one that in the gray color? Again, pi r square into height, multiply by height, right? Try not to use the word into because it's not the correct grammar, right? So if you use the shell method, there are two methods. Introduce you the first one, shell method, where we integrate the dy. When you get dy means you get this length from this length, and then you multiply by the height, right? So to get the volume, dv equal to 2 pi r. Your r is your y, z is your height, multiply by dy, you get your volume. Makes sense? Okay, so means this small shell here, how you calculate this small shell? You calculate the pi r square, the inner circle, multiply by dy, multiply by dz, you get the shell volume. Makes sense, huh? Okay, now recall just now your second moment of inertia. Integrate r square rho dv, you pull your rho outside, you get your integrate r square dv. Now if you're using shell method, you substitute this one inside here, but now you can no longer integrate v. What you integrate? Y, yeah? Okay. So same. Okay, so this is the first method. You calculate the volume using this method, shell method. Another one, same object, but now you're using this element. How you calculate this volume of this? How you calculate volume of this? Pi r square times dz. But what is there any r here? Okay, pi y square multiplied by dz. Right. So your v equal to pi y square dz. Again, recall what is your second moment of inertia. Integrate r square rho dv. Again, pull your rho outside. What is your dv? dv equal to pi y square dz. So now what you integrate? Huh? Your what is changing here? Z, so just pay attention to how the way you find. If you're using shell element, you're integrating y like this. You're integrating y if you use shell element. And this one is from you are focusing on y axis. If you're using this element, you are using z axis. Both give you volume, right? So why we introduce you to a method? Because it depends on how you calculate which axis you refer for your initial second moment of inertia, right? Okay, so again, this one, just a highlight. This equation you cannot use to find moment of inertia z of the body about z-axis directly. Yeah. So just remind, because do not lie at the same radius distance r from the z-axis. So here the r was not same. The y is not same. Okay. Okay. So just as a homework, determine the moment of inertia of cylinder about z-axis. Density of the material, typo error is a rho, is a constant. So how do you find second moment of inertia for this object? Okay. What is the second moment equation? I equal to integrate rho, sorry, r square dm or rho r square dv. Okay. So this method, how you calculate? There are two methods. You can use shell method. If you use shell method, what is the equation? Huh? Huh? Shell method. Just now, we introduce you shell method. You understand what is shell or not? Okay, this is shell. This is this method. So which one is first one? Which one is second one? So we are using shell method. What is your equation of moment inertia? How you calculate shell volume? Huh? Pi multiply by, what is your height here? Again, we are doing shell method. Is this shell method? Huh? Okay. Let's repeat one more time. What is shell method? What is this method? How you calculate this volume? A shell method. How you calculate this shell? How you calculate? You calculate the inner radius of this one, inner circumference. How you calculate inner circumference? How you calculate this distance? How you calculate circle circumference? Huh? 2 pi r. You get inner. Then you integrate here to here. Here is dy. You integrate dy, you get the thickness of here. Then you multiply by height. If you use shell method, dv equal to 2 pi r, 2 pi y, multiply by z dy. Okay. What about this? This element? How you find this element volume? You take area, multiply by height. How you get area of a circle? Pi r square. In this case, pi y square, multiply by height. How to find volume of the disc? What is changing? What is changing? Y changing or Z changing? Z changing. Integrate dz. So pi y square dz. You integrate z. For shell, what is changing? What is changing? Here, changing. That's why you integrate y. How you find area of this small disc? How you find area of the highlighted? Pi r square full circle. How you find this ring? You can do that, but if you're forced to do integration, how do you do integration? The okay. This small changes is dy. This is y. What you do, you take circumference, multiply by the change of area in term of dy. You get the ring, right? How to get circumference of inner circle? Huh? Huh? In this case, 2 pi y. How do you integrate the area that I highlight on the whiteboard? Integrate dy. Then multiply by z. Okay. Any question on the this and element? This and shell. Now back to the question. If you use shell method, how to find second moment of inertia for this rock? You use shell method. What happened to your inner cylinder? What is your R? What is your Y? Huh? What happened to your R? What is the value of R if you have full? Here become this one. What happened to your Y? What is the value of your Y? You know how to do ring. You don't know how to do full circle. What happened to your R? How you get? How you change this one to here? This one. This one. 2 pi R dr, right? Integrate dr, right? Correct? Yeah. I do it slowly for you. What happened to the R? Do you see the transformation from here, here, here to here? What happened to your R? What happened to your R? What should you do with the R so that you get this shape? Huh? Correct. You decrease your R, you'll get full circle. Okay, simple logic. Right. So same with this one. How you calculate volume? You continue to do 2 pi r, a small one, h dr, right? So the mass will be rho dv. You substitute your v inside here, right? So I equal to integrate r squared dm. So you pull this whole thing into here, change your integrate with r. You pull all the constant out. Rho is constant, pi constant, 2 constant, h constant. You arrive at r squared, r cubed dr. What is the final integration answer? Huh? R 4 divided by 4. Okay. Now, uh, here you get something divided by 2. We want to change this term in terms of mass. How do you get mass? How do you get mass for this object? How you calculate mass again? Density multiplied by volume. Do you see volume here inside? How to get volume? How you get volume? How do you get volume? Right? So how you change this one into that term? Sorry, this is not volume, it's mass. Put that equation in terms of mass. How to write in terms of mass? How to write in terms of mass? Yes. How to fit this? I don't want to see this one anymore. I want to see m. What happened to your equation? What is your mass again? Rho pi. What is the remaining one? H R what? So what is the equation become? M H R square divided by 2. Hey, sorry. This one haven't get your mass. Is it correct? Is it correct? Mass equal to rho multiplied by area. Is it correct? This is wrong. It should be volume. So how to get volume? So here, here, please pay attention. Okay. So at the end, you get half mr squared. Make sense? So for this chapter, you don't need to memorize the second moment of inertia. There's a table for you to refer, but you must able to see which one is which one. Right. So there's a table, inside table later. I'll show you where to look for this one. Okay. Now, second example. You have this shape. And this shape, the y square equal to x is this curve. And you have a cylinder base, not cylinder base, a circle base with 1 meter radius, 1 meter height. Density is given 3,000 kilogram per meter square, meter cube. Determine the moment of inertia in solid about y-axis. So how do you get this one? What is second moment of inertia? Integrate. Or L square rho d v. How you get volume of this shape? In, what is your answer? 1 times 1 square. This is your R, okay. Multiply by 1. You try to check your answer. Pi R square, what do you get? Multiply by 1, what do you get? What shape you get? What shape it is? How to get that one? This is a mathematical question, not engineering dynamic question. How to get this shape? Huh? Again, we are using integration. How to get this volume? Think before you answer. How you calculate this volume? I think this question come out in your Max 2 or Max 3 final exam with integration. Just now I asked you to recall, right? Triple integration. But do you see Z there? Actually, there's a Z there. Okay, this one you go home and check. I'll not go into the mathematics. This element, how you find this element? This element, you take area, multiply by the height. So how to find this area? By R square. What is your R in this diagram? X, right? So what is your X? So your equation become pi y square, okay? Right. So your dm equal to rho dv. Think before you ask question. How you find volume of this? Take this equation, look at the PowerPoint slides. Now change your axis. X is here, Y is here. So your equation equal to what? Before you change your Y, what is your R? In this case, what is your Z? What is your Z in this diagram? Y. This diagram, what is the equation between X and Y? So what does this become? I. Okay. So pi y squared power 4 just now. You can put in terms of dm, right? So again, this one is you already know already. So rho m, right? So m okay, dm. How to find dm? Dm equal to rho by r square dy. Rho volume. So you substitute this one, you rearrange the equation, you get rho pi x square dy x square. Substitute your rho here, and then substitute your x equal to y square. Then you integrate with y, you'll get x power 4 dy. Your x is from 0 to 1. So you get so you get y power 8 because your y square, correct. So you substitute your x equal to y square, you get y power 8, right? So we can do the calculation. The answer will be 500 something. Huh? So there are many ways of calculating the volume. Just need to be careful what is changing in the calculation. In this case, what is changing? Your dy is changing. Okay. So how do you know when you need to use shell method, when you need to use this method? How you know? Recap. Shell method, what is changing? Huh? This one. This axis change, right? Dx or dy doesn't matter. So this axis change. This method, what is changing? Dz, dy or dz doesn't matter. Is this changing? So you look at the diagram, you're using your dy as changing this one. So when you integrate, right, you are using the y-axis as your reference. Okay, so it depends on what axis you are referring to. Okay, so normally this is your z, but it can be y, it can be z, it can be x also. It depends on where you're looking from. Okay, so go a little bit more. So we start to introduce you a parallel axis theorem. What is parallel axis theorem? Let's say you have a body, you have a center of gravity, center of mass, and then there is an interest of mass, a small mass that you want to study. You have a fixed reference plane, Z, and then your x-axis is a static observer at point A. So when you look at from A to the M, and then there is a translating axis, x prime, y prime. Let's say your distance from center of mass to the dm, you get x prime. And the height of your y from the center of mass axis is y prime. This is a right angle triangular. This is a right angle triangular. How do you find R? Huh? If you have this distance, how you find R? Check your answer. What is your length for the center, for the base of the? I'm asking you how to find R. You have A and B. How to find R? A squared plus B squared square root. From this diagram, what is your A? Huh? D plus x prime. It's not D x prime. It's D plus x prime. Square plus y prime square. And then square root. Okay. So the rest you read. Right? The rest you read. So you use Pythagorean theorem because this is a right angle triangular. So R square equal to the base square and the height square root, right? So again, recall what is your second moment of inertia. I equal to integrate R square dm. What is your R? Now you change this one. You take this one, substitute inside here, you do the integration. Okay. So you have two parts. This one you square. What is the product of this square? D square plus what? Huh? What do you get? D. You understand that you are having this one, right? So what you get? X prime square D. X prime. X prime. Correct. Hey, this is mathematics, eh? X prime no two there. Huh? So what is missing? You know how to do this one, right? Don't scare me. This one you also cannot do, then we cannot continue with it. Okay. I'm not sure whether your lecturer tell you there's a shortcut to calculate this one. D square. This one, 2 multiplied by this one, multiplied by this one, you get 2 dx square plus x square. Okay. You are at university level already. You should not use your SPM level, secondary level. Take this one, multiply by this one. You should already start to use faster method to calculate. Although you get the same answer, but the intelligence level we expect higher. Because you have lots of equation you need to solve. This one you still can do, but you won't have enough time to solve question in final exam if you use this method. Right? So you will get this one, you will get x prime square plus y prime square dm plus 2d xm dm from here. Combine this one and this one and this one. This one. X square. Right, plus you have y, right? The one that I write on whiteboard is only the front. Okay, so you get this equation. So what does it mean? There's one more. There's one more. So there are 3 components if you do integration, right? So you have when you derive from this equation, second equation here, you square this one plus this one, you integrate again, right? You will get first term, second term, and last term. First term, y square plus y prime square plus y prime square. This one, the first one, if you look at this diagram, x prime square plus y prime square equal to what? Here. From where? Center of mass. So the first one, it gives you second moment of inertia from center of gravity. Okay. Second one. Second one equals 0 because it passed through z-axis from the center of mass. Okay, so when you integrate x prime dm, this one, you pass through the z and you multiply by d, because here, integrate x prime dm, your x prime integrate with dm, You can cancel, you can cancel because z-axis pass through the body center of mass. Then the last part, this one is the total mass of the body. Okay, so we derive using the moving axis here, x prime, y prime, and focus on single mass. So we derive I equal to integrate r squared dm, substitute r squared equal to d plus x prime square plus y prime square. This one inside here, you do the derivation, you arrive at 3 terms. But one of the term becomes 0 because this one passed through z-axis. So you have the effect of center of mass, G, and the total mass of the body. Okay. You can simplify the above equation. I equal to Ig plus m d square. Because if you integrate this one, you get m multiplied by d square, you get this one. So a complete if you use a parallel axis theorem, this is the equation we are looking for in your answer. Okay, this one means that you are looking from center of gravity, G. Means the total moment inertia have 2 components. One is center of gravity plus the mass effect. Okay, standard already. This one, I think you see this one also in your statics. All right, so important. If you have composite body, means you have more than one body with different properties, then you do one by one. So for example, if you have a rod combined with a with a belt, so this is body 1, this is body 2. You need to do 2 sets of I equal to Ig plus Md. First one you do for the first body plus the second body. From where? From a reference point here. Or you pick a reference point. Normally we'll pick the one at the end. Okay. This one, how to find Ig? There's a table there. Refer to appendix inside the canvas. Okay, this one. This one will be given. But again, don't refer to the wrong value, especially here. Okay, all these are popular shape. Okay, so that's why chapter 6 is not a hard one. It's only whether you know how to use the table. And you no need to memorize actually. The only one equation you need to memorize this one. I equal to Ig plus Md squared. Yeah.
We need to memorize
This table, all this value here, center of gravity and mass moment inertia of homogeneous solid, all this value is this one. This one you need to calculate. This one you read from table. You take this value from table, you calculate, you plus md square, you get the total moment inertia. Then later, moment inertia will change to energy, will change to motion. You need to use this one, multiply by the motion reaction. What is D inside this table? What do you see? From where? From a reference point. Okay. Now, for example, if you have this body, where's the reference point? Here. So for the first object, your D it can be 0, but for second body, you're measuring from this to here. So your D will be referring to that one. Okay. So again, this one This equation you learn in your static already. And you pass your static, so I assume you already be expert in this one. Okay. This one. The principal idea is this one and this one, because the shape inside the question will change. So no choice. No use if you just memorize one fixed equation for one particular shape. You'll be in big trouble if you only remember. Let's say you only remember cylinder. What happens if I give you a hexagon or pentagon shape? And then you need to find the moment of inertia of this one. Okay, it still go back to the fundamental. I equal to integrate r squared dm. And to find the total ig, I equal to ig plus md square. Ig, you refer to table. Okay, so you will have all these simple element. This is only part of it. If you go to appendix, you have more shape of this one. All right. Okay. We have a short break. We continue with example 3 later. Okay, we have 10 minutes breaks. We continue 9:10.